Hi guys, today marks our last day of notes. We're just reviewing solving trig equations on these slides. There's just a few of them today, and then we're gonna have a couple days of review, and then we'll take our chapter 15 test. So let's try some of these problems. So here we go. I see a trig function or trig equation, both in terms of cosine on both sides. But one of them is a double angle formula for cosine, so I'm going to swap that out for the trig identity. And please remember that you will be given these on the test, a copy of them. Okay, so I have my, I'm struggling here. There we go. So I'm going to change cosine 2x out for, remember there's 3 that you can pick from. I'm going to do the one that's in terms of cosine, so I can keep this equation in terms of cosine. And then I'm going to move that cosine over. And I see that it has the form of a quadratic. It looks like something squared, and then the linear term in the middle, and then the constant. So I'm going to factor this, 2 cosine x, and then to get a 1, I have to write 1's in the back, and I need negative cosine, so this must be a -1 and a +1. So then I've got 2 equations that I'm going to set equal to 0, and I'm going to solve each one. I'm going to subtract 1 and divide by 2, and I get -1/2, and add the 1. So now we're in terms of the unit circle. Where is cosine x equal to -1/2? That would be here and here. It'd be half at pi over 3, so x is going to be at 2 pi over 3 and 4 pi over 3. And then where is cosine x equal to 1? The x value is equal to 1 at 0 and at 2 pi. Let's check our interval. I think it was at the top. So our interval is, it includes 0 but not 2 pi. So I'm going to go ahead and pretend like I didn't write that one down. And highlight. So this particular answer has 3 solutions to it. 2/3 or 2 pi over 3, 4 pi over 3, and 0. Okay, let's try the next one. So I see another double angle formula for cosine, and on the right there's a sine. So I'm going to use, instead of the one that I used on the last problem, I'm going to swap out for the equivalent 1 minus 2 sine squared x, and I picked it because now this entire equation is in terms of sine, not sine and cosine. Okay. The rest of the problem is done in a similar way. I'm going to chuck everything over to the right-hand side. I like to keep my quadratic term positive. I think it's easier to factor. Subtract the 3. I'll try 2 and 3 to start. I think that's going to work. And 1 and 1. And I need a positive sign in the middle. So this one must be positive and this one must be negative. Okay, so I'm going to set 2 sine x plus 1 equal to 0 and 3 sine x minus 1 equal to 0. So I'm going to get sine x equals -1/2, sine x equals 1/3. Now that's going to be, we're going to have to deal with that in a different way, but let's do the first one. Let's do sine x equals -1/2. Those are down here in the 3rd and 4th quadrant at pi over 6's, so we'd get 7 pi over 6 on the left, and we'd get 11 pi over 6. My pi has extra legs. And 1/3. 1/3 is not on our unit circle. I know it's sine is positive here and here, but if I have to write my answers as exact, I don't know where that is, so I'm going to have to do this. I'll write inverse sine of 1/3 is one of the values. That's this one. And then I need to figure out how to find that one. Well, to get that value, you would have to take pi and subtract inverse sine of 1/3. So we haven't done that before, but normally our answers fall in the unit circle. If you were allowed a calculator on the test, you could just put those values into a calculator. But those are the exact answers. Okay, for 25, it's similar to the last 2 questions that we've done. I'd like you to pause the video, try it. I'm going to work through it right now without any audio, see if we get the same thing. Okay, so you can see my 4 answers. I have work this out. It's a very similar question to the last one we just did. I don't know why I did that. There's supposed to be a highlighter. I've got 2 pi over 3 and 4 pi over 3. Second one, I ended up getting that 1/3 again. Remember, cosine is positive in the first and fourth quadrant. To get the first one, it's just inverse cosine of 1/3. To get this measurement, you'd have to take 2 pi and subtract that value to get that measurement. So those are my third and fourth answers. The 33 is a little bit different, and it's going to take, so I'm going to switch out sine. Double angle formula for sine only has one option. It's only 2 sine x cosine x equals tangent x. 3 different trig values. Okay, so why don't we swap out tangent for sine over cosine? So we at least can get rid of that. Okay, and I always try to get rid of fractions, so let's multiply by the common denominator, which would be cosine. So we get 2 sine x cosine squared x equals sine x. And now we have a quadratic, so let's move everything to one side. Cosine squared x minus sine x equals 0. And then I see right away that I have a sine x and a sine x, and I'm going to factor that out. So I'm going to take out one set of sine x, and I'd be left with 2 cosine squared x minus 1 equals 0. And now I can set my pieces equal to 0 and solve. So sine of x is equal to 0 at 2 places. It's equal to 0 at 0 and 0 and 2 pi. I'm going to go with the 0 and pi and 2 pi, and I'm going to go with the last, at the top of the slide it said 0 to 2 pi, not including 2 pi, so I'll just do 0 and pi for the left side. And then for the right, I'm going to add the 1 and divide by 2. And then I'm going to take the square root. And what's going to happen is you get plus or minus the square root of 1 over root 2, which is equivalent to, should say equals, plus or minus root 2 over 2. That happens at 4 different places on the unit circle. That is at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So this particular question has 6 answers to it. Pretend that's red. Practice to get used to these. Okay, last question of the day. I would like you to try it. Go ahead and pause, play around with it, see if we get the same thing. Okay, so here's my work. I moved everything over, factored out the cosine. Cosine of 0 is equal to pi over 2. Cosine of x equals 0, so x must be pi over 2 and 3 pi over 2. The second set, you get cosine squared x equal to negative 1. If you took the square root, that wouldn't exist. So this one only has 2 answers. Okay, so if these slides were okay, I'm hoping that they will be fine when we take our test. Like I said, we have 2 more days of review, and then it's test day. Come find me on Google Meet if you have any questions.